when you are the one sitting at the gate or on the tarmac hoping to get to your destination. So how can changes be made to make air travel even more reliably on time? NASA and its partners are pushing to make present and future travel more reliable with less delays and cancellations by improving our already robust systems. NASA as well as increasing fuel efficiency, while ATD-2 will develop and adjust precision schedules for gates, spots, runways, arrival and departures. And we will see how these ATDs are being used to develop innovative new partners have developed a new technology called Flight Deck Interval Management, or FIM, to minimize these types of delays and to make travel faster and more economical for all of us. Much of the early testing and research for this new approach was performed by using sophisticated computers and flight simulators at NASA field centers. But to make sure this system will work for commercial flights, NASA must now test this tech in real-world conditions on real flight tests. So NASA and its partners are here in Seattle, Washington, taking part in a comprehensive flight test campaign called ATD-1, or Air Traffic Management works like this. Air traffic controllers are in charge of the spacing and sequencing of all inbound aircraft. The air traffic controllers use radar to track and manage all incoming aircraft.
address that we think we've hit that limit, and we're looking for a new way to do business so that it is more scalable. Now we have the aircraft are actually sending out signals that all the other aircraft and the ground can see. And then the decision support tools that Ames built for the controllers and what we're building for the pilot allow the controllers and pilots both to execute to this much more sophisticated schedule than we have currently.
With this new technology, the pilots will no longer be reliant only on air traffic control, but can follow automated directions on their onboard flight deck interval management system.
Other so that we are getting more airplanes through. Right now, air traffic controllers space people further apart because they don't know necessarily the winds and how the airplane is reacting, because every airplane reacts differently. But if you put that information in the cockpit with the pilot and have the air traffic controller issue him a flight deck interval management, a FIM clearance, then he can space off the guy in front of him, so you're getting more airplanes through. It's not an easy problem to solve, because right now you've got everybody lined up, but what about when you have those guys coming from the other direction? You've got to create a space for them and slide them into the chain to get them in also. And so it'll be boom, boom, boom. Even when you get weather, you will be able to target them in and get more airplanes in and out so that you're increasing your throughput.
It works like this. This NASA-developed software keeps track of the speed and position of the airplanes as they approach an airport. GPS signals determine each plane's location and ground speed, then broadcasts this information to satellites and ground stations about once every second. The FIM system automatically calculates how fast the planes should be traveling to maintain the proper spacing between them, and displays that information on a tablet in the plane's cockpits. The pilots see their speed and the speed of other aircraft around them in real time, allowing for safe distancing until the landing gear touches the ground. Because this software can predict the moment when an airplane touches down within a few seconds, pilots and ground controllers plot each plane's route more easily and efficiently. With tighter spacing, planes won't loiter in the air as long, which means there is the potential to use less fuel, reduce noise and pollution for communities around airports, and have fewer flight delays for the flying public. Working with Boeing, Honeywell, the FAA, United Airlines, and others,